Hello, fourth grade, and welcome to lesson 9-5. In this lesson, we're going to work on subtracting fractions that have like denominators. Remember, when we say like denominators, that means the denominator is the same for both numbers. Let's go ahead and watch our short video, and then we're going to jump right in to our notes and our guided practice together.
How can you subtract fractions with like denominators?
We will learn how to do this a couple of ways.
Tanya is squeezing lemons to make lemonade. The recipe calls for 5/8 cup of lemon juice. The amount Tanya has squeezed is 3/8 cup. What fraction of a cup of lemon juice does Tanya still need to squeeze? How do you know that you are being asked to subtract to find how much lemon juice Tanya needs?
Okay, so here, stop and think. Look at this like a regular subtraction problem. She needs 5/8 and she only has 3/8. So we need to find the difference between those two numbers to figure out how much more she needs. So since we're working with like denominators, ignore the denominator for a moment. She needs 5 parts and she only has 3 of the parts. What do we need to do to figure out how many parts she still needs to reach 5? We need to subtract the 3 that she already has from the 5 that she needs to figure out how many more is still left over.
Since you know how much lemon juice is called for in the recipe and how much Tanya has so far, you have to find out how much more she needs. So you subtract. One way. Find 5/8 minus 3/8 using the relationship between addition and subtraction. Break 5/8 apart. Would it help to decompose 5/8 as 1/8 and 4/8?
Select your answer.
No. Since Tanya has squeezed 3/8 cup of lemon juice, you need to decompose 5/8, so one of the addends is 3/8. Write a related addition equation. 5/8 equals 2/8 plus 3/8. Write a related subtraction equation. 5/8 minus 3/8 equals 2/8. Another way. Find 5/8 minus 3/8 using a general method. 5/8 minus 3/8 equals n. What does the bar diagram show?
Okay, so here let's stop and think for a minute. What they're doing is they're showing you related problems, which means these are all part of a facts family. Remember, anytime you're adding two numbers together and getting a third number, you've created a facts family. So you can add or subtract within that facts family. Now for this one, they're showing us a bar diagram. 5/8 is the total that she needs. So 5/8 is what goes on top. And then the part that she already has was the 3/8. N stands for the number of parts she still needs. So you can show your subtraction of fractions in a couple of different ways. You can use the number line where you start with 5/8 and you jump back 3/8 to see how many are left over. You can decompose 5/8 into 3/8 plus something else. You have a lot of different strategies that you can work with here, but make sure you're familiar with how to use a number line, how to use a fraction strip, and how to use a bar diagram, because these are strategies that are going to make it a lot easier for you to see and visualize your problem while you're trying to solve.
The bar diagram shows the whole, the known part, and the unknown part. Subtract the numerators. Write the difference over the like denominator. 5/8 minus 3/8 equals 5 minus 3 over 8, which equals 2/8. 2/8 is equivalent to 1/4.
Okay, let's pause for a second here and take a look at what they did. Now here you can see that they put both numbers over the same denominator. Now our denominator isn't changing. They're both 8s. So here they did the 5 minus the 3, which is all going to be in 1/8 size pieces, and they made it 2/8. So this is just a different way to write what you have over here. So don't let it confuse you. Now over here, when they got their answers 2/8, we know that since these are both even numbers, we can divide them by 2 to simplify our fraction, or to make it into the smallest, to give it the smallest possible numerator that we can while still being equivalent. So 2/8 is equal to 1/4 here.
Tanya needs to squeeze 1/4 cup more lemon juice. Now you know how to subtract fractions with like denominators.
All right, let's go ahead and jump into our notes and our guided practice. Now, our notes for today, 9-5, subtracting fractions with like denominators. How can you subtract fractions with like denominators? Well, you can use a fraction strip, you can use number lines, or you can use bar diagrams. Remember, you do not change the denominator when you're adding or subtracting fractions. Your denominator stays the same. So I gave you an example question here. It says Leah and Josh live in the same direction from the school on Forest Road. Leah's house is 8/10 of a mile from the school. Josh's house is 5/10 of a mile from school. How much farther does Leah have to walk home once she reaches Josh's house? So she's 5/8 away, or sorry, he's 5/8 away, and he's 5/10 away. My apologies, guys. And she's 8/10 away. So after she reaches his house, how much more does she have left to walk before she gets to her own house? So the first thing I did here was I drew it on a number line. And I wrote down what I know. So my number line, I broke it up into tenths. We know that the school, we're going to mark it the 0 point. We know Josh is 5/10 away and Leah is 8/10 away. So what I need to figure out is the space in between. How many more tenths of a mile does she need to walk to reach her house? So I know that it takes 5/10 of a mile to get from the school, from Josh's house to the school. And it takes her 8/10 of a mile to get from the school to her house. So I need to find the difference between 5/10 and 8/10. So once she reaches Josh's house, how much farther does she need to go? So I need to find the difference between 5/10 and 8/10. So what I'm going to do is I'm going to do 8/10, take away 5/10. And you can see that I'm just carrying over my denominator. I'm just copying it over, and I'm working just with my numerator. When I subtract 8/10, take away 5/10, I find out that I have 3/10. Now, if I want to draw this as a bar diagram, I'm going to draw it with my 8/10 on top because that's the total distance to her house. We know part of the distance is the 5/10 that gets her to Josh's house. And then she needs to figure out how much farther she has to go past Josh's house to reach her house. So I can write it as a subtraction. 8/10 minus 5/10 equals my mystery number. Or I could write it as a related addition sentence. 5/10 plus a number gets me to 8/10. And that's how I can answer that one. So for our next example, we're going to find 3/4 minus 1/4 using a bar diagram to show our work. So my big number, my starting number is 3/4. That's going to be right here on top. The part that I know is 1/4, and I have to figure out how much is left over. So 3/4, take away 1/4 equals my mystery number, or 1/4 plus my mystery number equals 3/4. Over here, you can see that I just carried my denominator across, stayed the same, and I only worked with my numerator. If I have 3 pieces and I take away 1 piece, I am left with 2 pieces. Now this works even when you have improper fractions like this one. 19/10, take away 8/10. Now 19/10 has a larger numerator than a denominator. That's why it's called an improper fraction. But I can still do the subtraction. So my 19/10 goes on top of my bar diagram. My 8/10 is the part that I'm taking away. And my mystery number is how much I'm going to have left. So here I'm just carrying my denominator across. 19/10 minus 8/10 equals something over 10. 19 minus 8 is 11. Now this is still an improper fraction, so I can rewrite this as a mixed number. 11 is one extra piece than my group of 10 over 10. So I have 10 over 10 plus 1 over 10, which is the same thing as saying 1 whole and 1/10 extra piece. All right, moving on, let's take a look at our guided practice. Says Jesse has a bottle that contains 7/10 liter of water. He drinks 2/10. Jesse says that he has half left. Is he correct? Explain. So let's work out the math. 7/10 take away 2/10 is going to give us 5/10. Now 5/10 we know is an equivalent fraction for 1/2, because if you do 1/2, you multiply numerator and denominator both by 5, you're going to get 5/10. Or if you took 5/10, you divided the top and the bottom by 5, because they're both multiples of 5, you would end up with 1/2 that way as well. Since they are equivalent fractions, he is correct. Number 2, what addition sentence can you use to subtract 4/10 from 9/10? So here they're asking you, what is your related addition sentence? So go back and think about fact families. If you want to do 9/10 minus 4/10 equals something, you can also think 4/10 plus something is going to equal 9/10. So 4/10 plus my number, my mystery number, is going to equal 9/10. So 4 parts plus how many more parts will give me 9 parts? I know 4 plus 5 equals 9. So my mystery number is 5/10, which is also again equivalent to 1/2. Now for our remaining questions, we're just going to be working these out one bit at a time. 2/3 minus 1/3. So if you have 2 pieces, you take away 1 piece, you're left with 1 piece left over. 3/4 minus 2/4 will leave you with 1/4. 5/6, take away 2/6 will leave you with 3/6. And this is also an equivalent fraction for 1/2. Whenever your top number is half of your bottom number, you know your fraction is equal to 1/2. So since 3 is half of 6, you need 2 groups of 3 to make 6, it's equal to 1/2. For number 6, 9/12 minus 3/12 equals 6/12. 9 minus 3 is 6. Again, this is another equivalent fraction for 1/2. Since your bottom number is double your top number, or your top number is half of your bottom number, your fraction is equivalent to 1/2. 9/8 minus 3/8 will give me 6/8. Now these are both even numbers. So I can actually keep going with this and say, okay, I can divide both of these by 2, and this will give me 3/4. So 6/8 is an equivalent fraction of 3/4. 17/10 minus 9/10. So 17 minus 9 is going to give me 8. 8/10. I know I can also divide the top and the bottom by 2 if I want to find an equivalent fraction. So this would be 4/5. For number 9, 4/8 minus 1/8 is 3/8. And then for number 10, 1/2 minus 1/2 leaves you with 0. You don't have any parts left over. All right, that's it for this lesson, 4th grade. This is the same process we were using with addition. You maintain that denominator, you don't change it, you're only working with your numerator. And then you can simplify your fraction by dividing it down into the smallest possible parts to find your answer. If you have any questions, let me know. Otherwise, I hope you have a great day. Take care. Bye-bye.